In this next problem, we're told that Ace Rentals rents a car for $29.95 per day and 31 cents per mile. Terry rents a car for 3 days. We'd like to know how far can he drive on a $250 budget. So he has to rent the car for 3 days. Now Terry wants to sit in the parking lot of the rental company for the next 3 days. He kind of has that right. But he's going to probably rent it and drive it. So generally speaking, in any problem with cost, there's two things we have to be aware of. Cost is always your fixed cost plus the variable cost. For instance, if you went to a car repair shop and had some service done, then a lot of times what they'll do is you'll have a cost for parts and then a cost for labor. The parts would be your fixed cost, labor would be based on how much time it takes to put it in. Now other mechanics may have set costs for certain jobs. Like you go get your oil changed, here's what it costs. It's a set amount. But part of that is a fixed cost and a variable cost still coming in. It's just not expressed that way for you. So here we realize that his rental per day, since he's specifically doing it for 3 days, that's fixed. Whether he drives the car anywhere or not doesn't make a difference. It's still fixed. So the first thing we realize is our fixed cost, $29.95 per day for 3 days. So we can go ahead and realize he has $250 to spend, so that's his cost. That's what we want it to be. And then that's going to be the fixed cost of 3 times $29.95. Then we have the cost that can vary. The cost that can vary here is his mileage cost. So we realize here that it's 31 cents per mile. We don't know how many miles he's driving. So that's our variable cost of 0.31 times our variable, which I'm just going to call M for miles. And so now we have an equation relating the cost to the miles driven. And we can set about solving that equation. So we begin first by multiplying out 3 times 29.95, the 89.85, plus 0.31 M, and then our goal here is to solve the equation. So we just keep the decimals as they are, and we subtract, right, 89.85 from both sides, right, so that we can get the M by itself. And when we do that, 250 minus 89.85 will give us 160.15. 160.15. And that's equal to 0.31 M. Now in this problem, we want the nearest mile. We want to the nearest mile, how far can he drive? We want to the nearest mile. How far can he drive? So when we divide by 0.31 for both sides, we get the answer 516.61. Now I know you're used to just taking a number answer like this and rounding it off, but here we have to give a little bit of thought. He can drive 516.61 miles on a $250 budget. If we round that up to 517, the cost is actually going to be a little bit more than $250, and that would exceed his budget. So here's a situation where we have to actually round down. Even though it's 0.61, it's big enough to go up. We have to go down because we want the nearest mile. We want the nearest mile only. So the actual answer is we can drive 516 whole miles on the budget. 517 would actually take us a little bit over 250. Now, in practical purposes, we say, oh, that's close enough. But in this problem here, because our budget is locked in at 250, we can't exceed that. So to the nearest whole mile, we can only drive 516 miles. So we have to round down here.